Hello guys, good evening. Welcome to our channel physicshub. Today in this session we will be discussing all the solutions from mathematical physics which came in CSIR-NET 2024 June. So what will be our approach? We will try to discuss each and every problem in detail so that you understand very well. So I hope everything is all right. Now from these questions you will get an idea what kind of question paper is set in your CSIR-NET examination, although you must have seen the solutions already, but today we will be doing it in a detailed way. Okay. So before I start, let me tell you guys, you can explore our physicshub courses. A lot of courses are there. This complete batch course for CSIR-NET December 2024 and GATE and BAR 2024 is ongoing. You can join this. Other than that, a top 100 most important topics course is available both in Hindi, English and English only. And PhD mock interview program is also available. If you are interested, you can go for it. All the things you can get from the website www.physicshub.in, or you can also install the physicshub application from the Play Store and you can purchase these courses. Now without any further ado, let's start. And guys, those who have not joined our Telegram channel, please join to download various PDFs. Okay, I thought it is stuck. Let's start with the first problem. Why is it lagging? Okay, look at this problem once, then we will start solving this. Very simple question. It's a good struggle to wear a spectacle. Look at this problem. It says an integral is given by this expression where a is a real parameter, the full range of values of a for which the integral is finite. Look, this problem is such a simple problem. Let me tell you why. Whenever, let's say, you solve an integration and let's say the limit of x become a minus infinity to plus infinity. So to get a finite result, this integrand must be converging, right? This is called integrand. This integrand must be converging. What does it mean? As you take higher values of x, look, the limit of x is going minus infinity to plus infinity. So for higher values, it must be converging, otherwise your integration will diverge. So this concept will be used here. You see, exponential, what is given to us? We are given exponential minus infinity to plus infinity dx minus infinity to plus infinity dy, exponential minus x square plus y square plus 2axy. So this exponential term, whole exponential term should be negative, so that this exponential will be exponentially decayed and it will get converged to a finite number. So to make this whole thing exponentially decay, this x square plus y square plus 2axy, it must be greater or equals to 0. Then exponential minus of positive number, so it will be an exponentially decaying function. So this criteria should be satisfied. Now what you can do, you can just do little bit of middle factor thing, x square plus 2 times x times ay plus, let's say, ay square. So 2axy we have taken, ay square we have taken extra, so we will just subtract y square minus ay whole square. We have taken ay whole square extra, so we are subtracting. Clear? I hope this is clear till now. So what are you getting? X plus ay whole square plus 1 minus a square times y square, this should be greater than 0. Now there is no problem with the first term, it is square, so it is always positive. Now it must be positive, y square is positive, so 1 minus a square must be positive for the whole thing to be positive, isn't it? So this requires 1 minus a square greater than 0, that means your a square is less than 0, and this corresponds to mod of a less than 1, and that implies minus 1 less than a less than plus 1. Tell me if you have any doubt in this question. Simple question. So option 3 is the correct option for this question. The main argument is the integrand must be converging, because the limits are minus infinity to plus infinity. So this was a good problem, and I hope everybody understood. If you have any doubt, you can let me know. Okay, we have to cover all the problems from mathematical physics, so we'll go a little bit fast. Let's go to this problem. This is a good problem. Vorticity of vector field V is defined as V equals to V cross B. It's a del cross B. This is the curl of B. B is kx y z r cap, where k is a constant. Which of the following is correct? So you see, curl of any vector, what does it give? Curl. Now V is equals to curl of V, so V is a kind of curl. Now curl is a general thing. Vorticity is what? When, let's say, you take a vector field, when you calculate a curl of A, of vector field A, that is called curl. When this vector A is a velocity vector, then that thing is called vorticity. So vorticity is like curl in the velocity field. So B is given to you k x y z r cap. So you have to find out which of the following is correct. Vorticity is a null vector for all finite values of x. To check this, you have to find out V, isn't it? In the beginning, y positive. Okay, I don't know why my laptop is lagging today. Look, why positive? Because you see, it should be exponential, it should exponentially decay. Okay, this whole thing should be negative, means minus x square plus y square plus 2axy. This will be negative only when this is positive. If it becomes negative, then negative into negative, it would become positive, na? Then it would become exponential some positive number that will be diverging. So what will you take so that this exponential thing gets positive? This exponential thing get exponentially decaying. So if you choose this part positive, and with this negative, this whole term will be negative and it will be converging. That is why you have taken positive. Understood? Let's move on. Look at this problem, vorticity. Let's solve this. Vorticity is defined as curl of B. You must have read about curl. Now this problem can be done in different ways, in different coordinate system. Although it is given in terms of r cap, my suggestion would be, if you do it in Cartesian coordinate, then that will be easier to handle. If you go for spherical polar, that will be very difficult to solve. So I will solve via Cartesian coordinates. So first of all, what is this r cap? Let's evaluate the value of b first. Then we will calculate curl of b. This problem will be little bit lengthy, but I will try to give you detailed solutions. So b is equals to k x y z r cap. So we can write it as k x y z. R cap means vector r by modulus r. No issue in this. And that thing can be written as, r is equals to x I cap, y j cap, z k cap. This will be root over x square plus y square plus z square. No issue in this. So let's separate these terms on this page. So this will become k, if we take common, what we will have, x y z is multiplied with each term. So x square y z divided by root over x square plus y square plus z square times I cap plus x y square z by root over x square plus y square plus z square times z cap plus x y z square. You need to have patience to solve such question, otherwise these questions cannot be solved inside the examination hall. So b we have found out, and from this b we can find out the vorticity v. V is equals to curl of b. As we are dealing with Cartesian, we have converted this vector b in the Cartesian form. So k is a constant, let's keep it aside, and you know the formula for curl, how to determine curl, I cap, j cap, k cap. Then you write del del x, del del y, del del z. Then you write the components of b, which is this x square y z divided by root over x square plus y square plus z square, x y square z by root over x square plus y square plus z square, x y z square. Look, the calculation will be little bit lengthy, but the overall problem is quite simple. Okay, now just expand. Once you calculate this vorticity, it will become very easy for you to handle the situation. Look, now all the terms are very symmetric here. So if you calculate I cap, we can easily predict what will come for j cap and k cap. So let's calculate ith term first. Then from similarity, ith component we will calculate first. Then from similarity we can write jth or kth term. Okay. Ith component, what will be your ith component? Let's this k is multiplied, so let's keep it as k. Okay. Then I cap. Look, I cap. So del del y of this thing. So the first term will be x z square divided by root over x square plus y square plus z square. Another term will come minus x y square z square divided by x square plus y square plus z square to the power 3 by 2. This is the first term you will get by taking this I. Okay, let me show you. Although you know already, I, we are taking del y of this. Next what you have to do, minus del z of this, right? So another term will come and it will be similar, very similar, del z. So from the first term z will be missing, xy square divided by root over x square plus y square plus z square, and minus x y square z square upon root over x square plus y square plus z square. This is the first term we are calculating, ith term. So if you calculate this, what you gonna do, what you gonna get? As you can see, this term and this term, it is getting cancelled. So you are getting I cap kx, if you take common, z square minus y square divided by root over x square plus y square plus z square. Okay, is it clear till now? Now as you can see, is this term 0? This term is not equals to 0. And can you not write the jth term, jth component using the similar calculation? Jth component will be here I cap, that will be your j cap, kx, so it will be ky. You see z square minus y square, so what will it be? Y, so it is like x y z, x z square minus y square. So when you are considering y, what will be that? X square minus z square, you are going back, divided by this root over x square plus y square plus z square, and as you can see, this is also not equals to 0. We are basically trying to prove the first point. Vorticity is a null vector, so it is not a null vector because you are getting the component not equals to 0. For null vector, the component should have been 0. Okay. To the root was there, but after derivation it becomes 3 by 2, isn't it? Just give me a moment, guys. Here only we are writing the kth component. Kth component will be k cap kz y square minus x square divided by root over x square plus y square plus z square. This is also not equals to 0. Therefore we can say that vorticity V is not a null vector for all finite x, y, z. I hope this is clear to you. Now vorticity is perpendicular to the vector field everywhere. So if you take the dot product, vorticity and the vector field, if you take the dot product, if you take 0, what does it mean? If you get 0, it means V is perpendicular to B. Okay. And if you get okay, for 0 you can conclude that it is perpendicular. So let's calculate that V dot B. Let's calculate. If you get it 0, then we will conclude that vorticity is perpendicular to the field. So let us now calculate V dot B. V you have already calculated and B also you have calculated. So what will be your V dot B? As you can see, this is the component of B, x component of B, and this is the x component of V. So if you take the product, what do you get? K square x cube yz z square minus y square. You will be getting the first term as like that, k square. Just take the dot product between b and b. B and b you have already evaluated, so that value will be x cube yz. Look, there is a strong similarity. If you just evaluate the first term, the next two terms can be written from similarity, and everywhere root over x square plus y square plus z square will come in the denominator. So x cube yz z square minus y square plus when you consider j component, then x y cube z will be there, because previously y square and this y, z square and z. So that corresponding term will be cube x square minus z square plus x y. You see x cube was there, y cube was there, now see z cube should be there, and it will be y square minus x square. Fine. Let's simplify this. This will become k square. So let's keep this denominator as it is. What are you getting? X cube y z cube minus x cube y cube z plus x cube y cube z minus x y cube z cube plus x y cube z cube minus x cube y z cube. And as you can see, everything will get cancelled. S cube y z cube, x cube y cube z, x y cube z cube. So this is 0. Therefore vorticity is perpendicular to B, perpendicular to the field B. Look, these problems are simple, but during your exam, if you are not so much careful, then you can make mistake. So option 4 is the correct option. Vorticity is parallel to the vector field everywhere. This is not parallel because we get this dot product equals to 0. So this is an incorrect statement. This is an incorrect statement. The angle between vorticity and vector field depends on x, y, z. So as this dot product is 0, the angle does not depend on x, y, z. So this is also not correct. Vorticity is perpendicular to the vector field. This is only correct. So option 4 is the correct option for this question. So I have given you the detailed solution why option 4 is correct. Okay, I hope everyone understood. If anyone has any doubt, let me know. Otherwise, we will go to the next problem. This problem, you can see probability density function of variable x is given by this, the variance of x is. This is a very simple problem. You need to visualize this first. You see, if you draw this probability density function, what kind of graph will you get? P of x versus x. So as you can see, this delta x plus a will show a peak at x equals to minus a, and delta x minus a will show a peak at x equals to plus a, isn't it? So 3/2 you missed in second term. Messages are coming so delayed. Okay, acha, this time. Okay, thank you. Okay, look at this problem now. So because of this delta x minus a term, you will get a peak here, and because of this delta x plus a term, you will get a Dirac delta peak here. this peak is corresponding to delta x minus a. This peak corresponds to delta x plus a. And as you can see, you know that when you take integration of a Dirac delta function, you get 1. You have to find out variance. Variance means what? Variance of x, variance is the square of the square of the standard deviation. Standard deviation is delta x, square of it. So this is x square average minus x average square. So this is the formula, you have to find this. Let's find this x average first. What will be your x average? Okay, x average will be minus infinity plus infinity. The way you find mean, x times px dx, this is the original formula, divided by the normalization. This is the original formula, right? So just put the values of px. So this will be equals to half minus infinity to plus infinity x time delta x minus a dx plus half minus infinity plus infinity x times delta x plus a dx divided by minus infinity plus infinity. If you take half common, what are you expecting? This minus infinity plus infinity px dx, this should be 1, na? Because total probability is always 1. Now we can use the formula. So this term on the numerator, look, half. What is the value of the first integral? Delta x minus a. So f of a. So f of x is x here. So if you put x equals to a, this will become a. And here you see, for this x equals to minus a. So you have to write minus a, half. What are you going to write here? 1 plus 1. So this is equals to 0. Understood how we calculated average of x? So we can use the similar formula to calculate average of x square. Similar formula, only x will be replaced by x square. So x square p of x dx minus infinity plus infinity p of x dx. Now as you can see, the term in the denominator is 1, means this p of x dx integration will be 1. So you have to only take care of the numerator. So half, let's take half common, minus infinity plus infinity x square delta x minus a dx plus minus infinity plus infinity x square delta x plus a dx. This is equals to half. If you put x equals to a, this become a square, plus here you have to put x equals to minus a. So this is a square, and that is why the variance, which is equals to x square average minus x average square, is a square minus 0 square is equals to a square, and that is matching with option 1. Final step of which problem? A minus A. Okay, this one. Okay, the Dirac delta lecture you did not complete. Minus infinity plus infinity f of x delta x minus a dx. This is equals to f of a. So here x equals to a, so a, here x equals to minus a, if it is plus, it will be f of minus a. Yeah, that is what I am explaining. Here you have to put x equals to a. So that is why a, and here you have to put x equals to minus a, that is why minus a. Understood? Here f of x is equals to x. In this expression, as you can see, f of x you consider like x, and so once you put x equals to a, once you put x equals to minus a, using these two formula. Got it? In the Dirac delta lecture I have discussed all of these things. Okay, look at this problem. This is a also very good problem. An astronomer observes 500 objects and classifies them as either type A or type B. So two possibilities. So obviously binomial distribution will come into picture. She finds 148 objects to be of type B. Assuming a binomial distribution, the best estimate of the fraction of type A objects. Here consider this term very carefully. This is fraction, it is talking about fraction. So you have to divide by the total number of trials. Here it is 500. Estimate the fraction of type A objects and its associated standard deviation. So a standard deviation formula you will use of binomial distribution. Okay. So in binomial distribution, let's say an event like tossing a coin, either you get a head or you get a tail. So two possibilities are there in case of binomial distribution. So for the time being, total number of observation is 500. Here the total number of objects observed बड़ी खतरनाक स्पेलिंग हो गया ऑब्जर्व का, is n. This is the total number of trials, you can say, number of trials you can say. Out of that 148 is of type B. So I can say n of B is 148. So what will be your n of A? So 500 minus 148, that will be n of A. Clear? No issue. Therefore the fraction of type A objects is, look, out of 500 352 is of type A. So 350 out of 500, that will give you the fraction of type A. So if you calculate, you will get 0.704. Okay, so you can also equate it 0.70. Now the fractional standard deviation you have to calculate. Let's do one thing, let's rename, you know, for binomial distribution we need probability of success and probability of failure. So let's call this event A as the probability of success. So the probability of observing type A objects is P. So P will be equals to 0.704, which you have calculated. And what will be the probability? The probability of observing type B objects. So observing type B object means not observing type A. So you can also write it that probability of not observing a type A object. If probability of observing type A object is P, what will be the probability of not observing it? 1 minus P. So 1 minus 0.704, 0.296 will come. So in binomial distribution we call it Q. Okay. Now you have to find out the standard deviation, but you have to consider the fractional standard deviation. What is the formula for binomial distribution standard deviation? For binomial distribution, the standard deviation is, let's say, K. What is the formula for standard deviation? Root over NPQ. This is the formula for standard deviation, root over NPQ. Now for the present case you have to find out the fraction of the standard deviation. So you have to divide it by the total number of trials. So when we consider the fractional case, then K is divided by the total number of trials. So fractional standard deviation is nothing but K by N. So it is root over NPQ divided by N, and it becomes root over PQ by N. So if you put the values, what is the value of P? It is 0.704. What is the value of Q? 0.296. N 500 total number of trials. This will come out to be 0.0204. You can approximate it to 0.02. So the standard deviation 0.02, and this probability of fraction of type A object is 0.70. you got the difference between this standard deviation and fractional standard deviation. The standard deviation root over npq, whenever you will calculate that, you will get a number. Okay, but here you see you get a fraction 0.02. Is it understood or not? Although we did not cover the probability distribution yet, but when you will cover probability distribution, then these things will be very easy for you. Let me know quickly if you have any doubt in this question. Let's go for this controversial question, random walk problems. A random walker takes a step of unit length towards right or left at any discrete time step. Starting from x equals to 0 at time t equals to 0, it goes right to reach x equals to 1 at t equals to 1. Hereafter, if it repeats the direction taken in the previous step with probability p, what is the probability that it is again at x equals to 1 at t equals to 3? This problem, look, in your examination hall, thinking this much will be difficult to you, okay, but try to understand. This is basically one dimensional problem. Let us try to understand this problem via graph. First of all, let us try to visualize the motion. A random walker takes a step. So let us say this is the origin, x equals to 0. Unit length towards right or left at any discrete time step. Discrete means t equals to 1, t equals to 2, t equals to 3, not t equals to 1.5 or 2.5. That is the meaning of discrete. So it can go to right or it can go to left with one step. Okay, so we are only considering the path, we are not considering time here. Starting from x equals to 0 at time t equals to 0, it goes right to reach x equals to 1 at t equals to 1. So at this point it is x equals to 1. Fine, this is the condition given to you. Hereafter, if it repeats the direction taken in the previous step with probability p, then the probability that it is again at x equals to 1 at t equals to 3 is. So look, previously it has gone in the positive x direction. So if it repeats its direction, so it should go to this position, isn't it? It should go to this position, it should reach to x equals to 2. Now what are the ways that it will be again found at x equals to 1? So it must come back to this point. Okay, is it clear or not? Now going from x equals to 1 to x equals to 2 in this direction, here the probability it gives you as p. What will be the probability of going towards left? Obviously it will be 1 minus p. Now you may ask a question, if there is only two options for the random walker, either to go towards right or towards left, why these probabilities are like this, p and 1 minus p? Why it is not half and half? Can you tell me? Why it is saying that it is the probability is p, so total probability of 1, so 1 minus p in the reverse direction? Why it is not half and half? Only two possibilities. One dimensional motion, it can go right or left. Can you tell me? Because This is a random walker. There is no foundation that he will equally move left to right. He can directly go towards right. Okay, he will not move towards left. So that is why this is the thing. So this one you visualize along the x axis. Now let's try to see this same picture in the x versus t graph. Then how will it look like? Try to understand this, x versus t. So let's say it has started from here, x equals to 0, t equals to 0. It goes right and reach x equals to 1 at t equals to 1. So this is t equals to 1. This is x equals to 1. So at x equals to 1, t equals to 1 means it has reached to this point. Clear? So it has gone let's say to this direction. Now try to understand it very carefully. Time will always be moving in the positive direction, 1 second, 2 second, 3 second, but position can be x equals to 2 to 1 or 2 to 3. Okay, now try to understand it. It goes right to reach x equals to 1 at t equals to 1. This point x equals to 1, t equals to 1. Hereafter, if it repeats the direction taken in the previous step, so this was the direction previously. So if it repeats, where should it reach? It should reach at x equals to 2, at t equals to 2. Now the probability that it is again at x equals to 1 at t equals to 3. At t equals to 3 it should come to x equals to 1. X equals to 1 is here, isn't it? So in which direction it will move? It will come along this direction. Now tell me the probability. Let's write the probability. Probability to go in this direction is p. Now you see, if it continues its direction with same probability p, it would reach at x equals to 3. It would reach at x equals to 3, but it has to reach at x equals to 1. So these two paths are opposite paths. Look, although in xt diagram it is looking like this, but in this diagram, as you can see, same diagram we have drawn. So here the probability is p, but here the probability will be 1 minus p. Understood this one? This is a little bit complex concept, but I hope you will understand. Now this is one of the pathways. You go from this to reach this point. Another possibility is that if you go along this path, then also you will reach this point. Instead of taking that path, if you, let's say, go along this path, then also you will reach. Now probability of going along this path is p. So what will be the probability along this path? 1 minus p, because these two are opposite paths. Here also you see, this is 1 minus p. Okay. So one thing you can write, probability to repeat direction equals to p, and probability to take reverse direction equals to 1 minus p. So, as there are two paths, one path is this green path, another path is two path. There are two ways to reach from this initial point to this final point. So, what will be the probability? Therefore, the total probability of being at x equals to 1 at t equals to 3 is equals to probability of path 1 plus probability when you choose path 2. So, either you go via this path or via this path, that is why this plus sign, A or B. So, what is the probability for path 1? It is p times 1 minus p. Probability for path 2, 1 minus p, 1 minus p. Okay. So, if you take 1 minus p common, p plus 1 minus p, this p get cancelled. So, we have 1 minus p. That is matching with option 1. This is also in the official answer key, and this is the correct answer actually. So, this was a little confusing problem, but I hope if you think about it, you can understand why it is. Let us go to this Fourier series problem, Fourier transform problem actually. At an integral transform f of x tilde of a function f of x can be regarded as a result of applying an operator f to the function such that this is equals to this. If I is the identity operator, then operator f to the power 4 is given by. This is a simple Fourier transform problem. As you can see, this formula, although it has been transformed into some other thing, but it is actually Fourier transform formula. If you compare it, minus infinity plus infinity f of x e to the power minus I k x dx. So, x has been replaced by y here and k has been replaced by x here. Otherwise, you can see, and 1 by root over 2 pi factor is there, but here it is not there. So, how to do this problem? Look, solving this kind of problem demands a lot of practice. If you are a beginner, then it may be difficult for you to solve this problem, but try to understand this. I am just providing you the solution. Fourier transform of f of x, this is given to you, that f tilde of x, and the formula minus infinity to plus infinity e to the power minus I x y f of y dy. Okay, this is given to you. So, what will be f square? Fourier transform of the Fourier transform. So, it is Fourier transform of this f tilde. Can you write it? This is equals to minus infinity to plus infinity e to the power minus I x y. We are applying this formula, e to the power minus I x y here we write the function. Okay, here it was f of x, so just change in variable, so f of y you have written. So here you have to write f tilde of x, so minus infinity to plus infinity e to the power minus I x y will not write, we will change the variable I y z f of z dz, and this dy was there. So within the bracket we have written the value of f tilde x, which we got from this expression. I hope this is clear. Little complicated, but try to understand. This is equals to minus infinity to plus infinity. Now let's write minus infinity to plus infinity e to the power minus I, if you take common, x plus z times y, this dy we can write, and fz dz. So we have just rearranged. This integration will give you terms of z, and later that remaining integration will be carried out with respect to z. देखो इसको समझ में आया कि नहीं? Have you understood this or not? Now one formula, very special formula of Dirac delta function is there. 1 upon 2 pi minus infinity plus infinity e to the power minus I k minus k prime z dz is equals to delta function k minus k prime. There is a formula like this. So that formula is very similar to this expression. So we can just write it as minus infinity plus infinity. This whole thing is 2 pi. This 2 pi is going that delta, whatever was there beside I, that will be written. So x plus z f of z dz. Now you know very well what is the integration of Dirac delta function. So x must be equals to minus z, or z must be equals to minus x. So f of minus x. So f square of this thing is 2 pi times f of minus x. Last step, above step. Look what I have done, and let me just explain it once again. F of fx, this is given to you, no problem in this. F square means we are taking Fourier transform of this Fourier transformed expression. So Fourier transform of f tilde. So what is the formula of Fourier transform? This is a general formula. So we have put e to the power minus ixy. Then you have to put the value of the function f of y. So here f of y is f of x here, f tilde of x. So that is why we have put this value. We are using ixy already, so we cannot use x here. So that is why we have changed the variable e to the power minus iyz fz dz, and this dy was there, so dy. Now exponential term we have gathered e to the power minus I x plus z y dy equals to fz dz into fz dz. So this value we have written by using this formula. Actually this is also a standard result. If you take Fourier transform 2 times, you get f of minus x. Okay, I have just proved it, although it is a formula. This is a property of Fourier transform, and this is the standard Dirac delta formula. If you have not watched the video lecture on Dirac delta, please watch that. After that, these things will not create any problem. Everything I have discussed in the Dirac delta function lecture. So once you know f square, we can easily calculate f to the power 4. F to the power 4 means f square of f square f of x. What's big deal? 2 f square multiplied will give you f to the power 4 f square. Now this value we have already calculated, 2 pi f of minus x, 2 pi f square of f of minus x. So we have seen that if you take f square of fx, it becomes f of minus x. So if you take f square of f of minus x, it will become f of plus x. Okay. So this is 2 pi whole square f of x, and from that you can write f to the power 4. You see, just compare, f to the power 4 you applied on f of x equals to 2 pi whole square. Now look, this is a number, but this is an operator, so that is why you have to multiply with identity operator to make it an operator. The way we cannot write I for a matrix, we have to multiply, let's say 1 or 2 or 3, we cannot write, we have to write 2i to make it a matrix. The same way we cannot write 2 pi whole square, we have to multiply I. So 2 pi whole square into I, that is matching with option 4. Tell me if it is understood or not. Very good problem. Let's solve the differential equation problem now. Look at this problem. The general solution for the second order differential equation d square I by dx square minus y equals to x sin x will be this one. I think many of you have done. Actually, for particular integral there were 4 formula. This problem is based on the last formula. One formula was there, if you remember, e to the power ax times I think v was there or something like that. 4th formula of particular integral. Okay, so this is a second order non-homogeneous differential equation. So this will have 2 parts of its solution. So given differential equation d square y upon dx square minus y equals to x sin x. So this will have 2 parts of the solution. One part is known as the complementary function. Let's calculate the complementary function. We have just covered this lecture few days back. Auxiliary equation you calculate m square minus 1, m is equals to plus minus 1. So your complementary function c1 e to the power x, c2 e to the power minus x. Let's go for the particular integral. What will be your particular integral? 1 upon d square minus 1 x sin x. Now this sin x is what? It is a complex or imaginary part of e to the power ix. We can write imaginary part of x e to the power ix. If you write sin x as e to the power ix minus e to the power minus ix by 2i, then the calculation will be lengthier. You will have to deal unnecessarily that real part. So that is why we are just writing that imaginary part of this. Whatever result you will get, you will just take out the imaginary portion. Okay. Now this is the formula you already know. If e to the power ax is multiplied, if you take out that first, if you write it like this, then your d becomes d plus a. So a is I here, so d becomes d plus a times x. Clear? No issue in this. Let's expand this. A square plus 2ab plus b square, so it is minus 1 minus 1 minus 1 minus 2. Look, this minus 2 we are taking common. What you are left with? 1 minus d square plus 2id by 2. Okay, no issue till now. This is equals to imaginary part e to the power ix by 2. Now this thing we are taking above, 1 minus d square plus 2id by 2 to the power minus 1 x. Clear? Now if you look at this, it is 1 minus x to the power minus 1. So what is the formula? 1 plus x square. But you have x. If you apply d on x, you get 1. If you apply d square, means double derivative on x, you get 0. Okay. So what you gonna get? This d square term will not be applied, only this d term will be applied. So 1 into x and from the formula there will be plus 2id by 2, so I times d of x, so that is I. This line needs to be understood. So this is equals to imaginary part of, let's say, minus half multiplied है cos x plus I sin x multiplied by x plus I. So what is the imaginary part? Minus half. You see, x cos x, real part, I sin x into I, so minus I square sin x, so plus I square sin x, so minus sin x, this is the real part, and I cos x plus I times cos x plus x sin x. So as you can see, this is the real part, this is the imaginary part. So when you take out imaginary part of this whole thing, so it is talking about this, and half is multiplied minus half, so minus half cos x or x sin x plus cos x to match with the option, and that is matching with option 1. Okay, let's write the total solution. For the sake of completeness, total solution is the sum of complementary function and particular integral. Complementary function c1 e to the power x, c to the power minus x, particular integral minus half x sin x plus cos x. Look at the options. Yes. Let's go for the new remaining problem. Okay, look at this matrix problem. The matrix A is given by this, the eigenvalues of 3a cube plus 5a square minus 6a plus 2i, I is the identity matrix R. How will you solve this problem? Look, the given matrix A equals to 1, 2, minus 3, 0, 3, 2, 0, 0, minus 2. This is, as you can see, these terms are non-zero and the terms below this principal diagonal is 0. So, this is an upper triangular matrix. This is an upper triangular matrix. So, for an upper triangular matrix, the diagonal elements will be the eigenvalues, hence the principal diagonal elements will be its eigenvalues. Okay, and hence we can write lambda 1 equals to 1, lambda 2 is equals to 3 and lambda 3 equals to minus 2. Now, to calculate the eigenvalues of this expression, we can make use of the Cayley-Hamilton theorem. So, let us write that. By using Cayley-Hamilton's theorem, the eigenvalues of 3a cube plus 5a square minus 6a plus 2i can be found out from the following expression. N is equals to 3 lambda cube plus 5 lambda square minus 6 lambda plus 2 by putting the lambda values. Okay. So, if you put lambda 1 equals to 1, lambda 1 equals to 1, you get n is equals to, if you put lambda equals to 1, 3 plus 5 8 minus 6 2 plus 2 4. If you put lambda equals to 3, you get n is equals to 110. If you put lambda 3 equals to minus 2, you get n to be equals to 10. Just put the value of lambda equals to minus 2 here. So 4, 110 and 10, option 4. So the eigenvalue of this expression, this will be a matrix, so its eigenvalue will be this. We could find it by using Cayley-Hamilton's theorem. Look, as this matrix was given to be an upper triangular matrix, we did not require to find out the eigenvalues. We directly wrote the principal diagonal elements as the eigenvalues, because that is a property. So if you have concept, you can avoid rigorous calculation. Otherwise, you have to find out the eigenvalues in the conventional way. Okay, so this was very easy problem. This time I am seeing that the problems are not all very easy, but it is moderate level and few problems are very simple. Okay, let's go for this very simple problem now. This is, I think, the easiest problem of the question paper, easiest. You are given the 4 matrices which forms a group. Now you have to find out which represent the multiplication table of the same group. So if you look at I into I is I, that is okay. I A into I A, B into I B, C into I C. So for all the tables this is true. Okay. Now let's move on. I into A is A, that is okay. A into A is I. A into A is I. Let's check whether it is correct or not. So this is equals to 1 0 0 1. This is identity. So A into A is I, this is correct. A into A is B, so this option is not true. A into A is C, but we are getting identities, this is also not true. Here A into A is A, I into A is A into A is I, so this is true. B into A is C, here it is given B into A equals to C, here it is given B into A is C. So there is no need to check, because out of these two problems one will be correct. So B into A is C given both place, C into A is B, C into A is B. Okay, so next A into B is B, here also A into B is B, A into B is C, A into B is C. Then you can see B into B is A, here B into B is I. So let's check this one. Here difference is coming. If you calculate A into B, then you will get C. You see minus 1 0 0 minus 1, but that is not useful. 0 minus 1 0. This is C. So this property holds. Now B into B, let's check what is B square. 0 1 1 0 0 1 1 0. So this is how much? 1 0 0 1. This is identity, and as you can see B into B is A, this is not correct. Then B into B is I, this is correct, and B into C is A. So option 4 is the correct option for this question. So I think this is the simplest problem or the easiest problem given in the whole question paper. Another very easy problem came from numerical analysis. Let's do that. So we'll be covering all the problems from mathematical methods in a single lecture. And for other subjects also we'll keep on uploading. Actually it takes time to actually solve all the problems in detail. Okay, you have to evaluate this integral using Simpson's 1/3 law, and you can find it out using the standard integration method. So first of all you need to know what is Simpson's 1/3. Simpson's 1/3 rule. Let me just write it briefly. If you have an integration like this, x0 to xn, this is the limit between which you are carrying out the integration, then it is equals to h by 3, h is the step size. Then you calculate y0, value of the function at the initial point, plus yn, value of the function at the end point, plus 4 times sum of odd functions y1, y3, y5 and so on, plus 2 times even y2, y4, y6 and so on. For this case, what you have, your f of x is 2x by 1 plus x square. H is given to you 0.5. So let's make the table. Here we will be writing the value of x, here we will be writing value of f of x. So it is like x0, y0, sorry, x0, x1, x2. Initial point is 0, step size 0.5, so next point will be 0.5, next point will be 1. So only 3 points. At if you put x equals to 0, you get value 0, x equals to 0.5 means half. So 2 into half, 1 divided 1 by 4, 4 by 5. If you put x equals to 1, so 2 by 2, it is 1. So this is your y0, this is your y1, this is your y2. Okay, simple. And hence I estimated is that result which you are getting from Simpson. H by 3, h is 0.5, y0 is 0, yn is y2, plus there is no even term, only odd term y1 is there, so 4 times odd term 4 by 5, 4 times y1. So 0.5 by 3 means 1 by 2 into 3, 1 by 6 into 16 by 5, 16 plus 5, 21 by 5. 3 से अगर काटो 3, 3 7 21 7 10, so it is 7 by 10, 0.7. So using Simpson's 1/3 we are getting 0.7. Now exact, you know how to calculate. I exact you calculate, you have calculated in your class 12. Let's do with A's. Look, let's do a little bit. Okay, we can write d of 1 plus x square. D of 1 plus x square is 2x dx divided by 1 plus x square. So this is coming in the form dx by x. So you can write it as ln of 1 plus x square, limit between 0 to 1. Put the limit, ln 1 plus 1, 2, minus ln 0, ln 1. ln 1 is 0, ln 2 is 0.693, and you have to find out the difference between I estimated and I exact. I estimated minus I exact. So how simple questions you were given in the examination hall. So it is, this is like 0.700, 0.693, 0.007. ठीक, yes. that is matching with option A. Clear guys? How many questions left? Okay, we have solved all the problems from mathematical physics. Okay, so in this video, those who have joined late, you can check all the mathematical physics problems. In the upcoming days, we'll solve and we'll take sessions on different subjects. And today we have covered all the solutions from mathematical physics. Before I end this session, let me tell you guys, our course is going on. You can join these courses, complete batch course on CSIR-NET, GATE and BRC. This course will remain valid till March 2025. And top 100 most important topics course is also available. You can also join test series and mock interview and all the links are given in the description. So this is all for this video guys. Thank you very much. If you are new to this channel, please subscribe to the channel and don't forget to press the bell icon. Finally, thanks for watching. For any doubts or query, you can let me know in the comment section, and I will try to share the PDF on our Telegram channel. So you can join our Telegram channel, this physicshub 111, link is given in the description to get the PDFs. Thank you very much. See you in the next session. Bye bye, take care.